Barry Perlus, who's been our colleague at Cornell and he has been associate professor at the Department of Art and in the College of Architecture, Art and Planning at Cornell University. He recently has become emeritus, so congratulations, Barry. His work he's an artist and educator who employs photography and digital imaging in his artistic practice. And he embodies a keen interest in observation and interpretation using elements of scale, perspective, light, color, abstraction to create new interpretations. And in recent project, Barry has been using panoramic imaging techniques as a departure from conventional pictorial space. With this approach, he developed a multimedia website about the large-scale astronomical observatories built in India by Singh in the early 18th century. Barry received his MFA in photography from Ohio University and his BA undergraduate scholar from Case Western Reserve University. Today, he's going to be talking actually about his work with the Astronomical Observatories. So welcome, Barry.
Thank you, Iftikhar. Thank you. And good morning, everyone. The talk today, as Iftikhar already mentioned, is about Singh's Astronomy Observatories, and it's based on this book, which just came out in July from Yale University Press, called Celestial Mirror, the Astronomical Observatories of Singh. As a way to begin, Iftikhar mentioned that I had developed a multimedia website. We're going to use the virtual tour from that website to all make a trip to India this morning. So you have to give me a moment here to do screen share. And I think, Daniel, you may need to bring that in for me. I am not seeing the option.
Mm-hmm.
Okay.
It should be at the bottom as you had in practice.
Yeah, but it is, let's see, there we go. Sorry. Oh, we just jumped ahead a little bit. So I just wanted to give you a sense of location here. We're looking at northern India. This is where Singh built his observatories. He was, of course, based in Jaipur, the city that bears his name, the region of Rajasthan. But he built observatories at 5 locations, really, and 4 of them are still existing. The one in Mathura is no longer extant. Most people who have visited have seen either the Jaipur Observatory or the Delhi Observatory. They are the best known, but there are 2 smaller, quite beautiful observatories in Varanasi and Ujjain, and we will go to see them. When they were built, 1723-ish to 1737, of course, most of the places were either relatively rural or small in scale, certainly. This is the aerial view in Delhi, and as we zoom in, you may be able to see the observatory here at the center of your screen. And you can see immediately how different it is from everything around it in terms of geometry. You see those 2 beautiful circular structures. We'll also look at Jaipur. Here's the city of Jaipur, and in towards the center is the observatory complex here in the center of your screen. The one in Varanasi is on top of Jai Singh's family's palace, the Man Singh Mandir. It is a little bit harder to see. The resolution is not quite so good for Varanasi. And then Ujjain is still a relatively rural area, mixed rural industrial with the small city. And the observatory is right on the banks of a small river here. So that was a quick glimpse of where these are. And now we've actually just landed. We flew to Jaipur. We're here at the observatory in Jaipur, standing on the top of one of the small instruments called the Rasi Valayas. I'm going to go into detail later on the tour. We just want to see things and get a little sense of what it's about. Looking here, as crossing the center of your screen, is the Jai Prakash, these bowl instruments, and we swing our way over. We're seeing now the gnomon here of the Great Sundial, which we'll take a closer look at as we move along. The Samrat Yantra is its official name, and here we've now climbed up to the top of one of the quadrants, and we're looking out over the observatory. This is the Jai Prakash, the bowl instrument that I mentioned a moment ago, a small Samrat Yantra, the Rama Yantra over here, the Rasi Valayas, 12 zodiac instruments. Here at the base of the quadrant is a quarter circle arc. It is where the shadow of the gnomon is a huge wall that casts its shadow. Here is the shadow, which marks the time. And one of the things about Jai Singh's instruments is that their scale was built extremely large. Here you're looking up to the top, about 70 feet above you is the top of the gnomon. The scale was so large, in his words, to enable much more accurate measurements, and he built them out of stone so that they would have permanence that the metal instruments of the day, the astrolabes, did not have, because through usage they became worn and less precise. This is another view later in the day, and you'll get to see a closer look at the quadrant, that curved scale that the shadow falls on. Here it's in the afternoon, about 2:30, I think, on a December day. And this is the shadow right down here. We're standing on a series of steps that climb along with the quadrant to enable the observer to follow whatever would be happening. If it was the sun's shadow, or at night they'd be taking eyesight-based instruments looking up into the sky. So technically this is a naked eye sky observation observatory. Everything is based on visual alignments between the structure and some object in the night sky, or during the daytime it would be the sun. And this scale, you can't see it here, but the markings on the scale go down to increments of 2 seconds. And it actually has that degree of accuracy. The shadow is a little bit soft, but I'll come back to that later, and also the accuracy there. Now we've just jumped down, and I'm going to try to pause here for a moment. Just jumped down from the Samrat Yantra to the other side of the observatory. We caught a glimpse of the Rama Yantra there. But we're going to swing across, and we'll see another view of the Samrat Yantra in the distance. But we want to take a close look at a smaller instrument called the kappala yantra. And we're going to look down here. The kappala yantra is unique because it was a model for the larger bowl instrument that we'll see in a moment. And if any of you know your astronomy, the kappala yantra included in it two systems or coordinate systems for sky observation, the horizontal system based on the horizon and the equatorial system based on projection of the plane of the equator, the Earth's equator, into space. And it allowed astronomers to make transcriptions between those two systems depending on which instrument in the observatory they used. So we'll move along. Here we have another view of that, probably the best view of the sundial. And we're looking down now into the bowl instrument called the prakash. In Jaipur, the instrument scales are all surfaced in marble, which was a late addition during one of the restorations. The original surfaces would have been lime plaster. But you can see the markings in the marble are very clear, and they show both the horizontal coordinate system and the polar or equatorial system. It's a closer view of the markings on those scales. The way this instrument works is you, as the astronomer, are down inside the instrument, and you have above you a sighting guide. We'll see that in a moment, but right now we're looking at the shadow of the sighting guide, which shows the exact position of the sun in the sky. The prakash is really, as a hemisphere, it's a mirror of the heavens above. And that, by the way, is where the name of the book, the title of the book, comes from. Because when you're in the instrument, you're inside a celestial mirror. So I'm going to pause for a moment, because one of the remarkable things about this instrument and the Ramyantra, and it is what sets Jai Singh apart from, or his instruments apart from all other examples of large scales astronomical observatories. You notice that there are cutouts in this structure, and there are steps, and this is where the astronomer would walk into the instrument, and you can see there are pathways to be able to navigate and get to any point on any of these surfaces. Now, these sectors, the white marble sectors, represent a 15-degree arc, which also, it turns out, equates to 1 hour of time. And if the observer is patiently making records of the position of a sky object, and he's tracking where that object is falling on the scale, sooner or later, he's going to get to the end of the scale. Well, at that point, he walks to the other instrument, because the two instruments are not identical, they are exact complements of one another. And where in this one, for example, that you're looking into, there's a solid scale, in the other instrument next door, it's a cutout. And what you see here as a cutout, it will be a scale. So the tracking of the object just continues hour by hour, 24/7, so to speak, by virtue of this design. And the Ramyantra is also sectored in that way. And so here we are down below. In a minute, you'll see the steps that we came down from our first place position, looking down into the instrument. And as we swing around, you see this is the passageway that leads to the second instrument. Some steps at the back to get up to the higher parts of the scale. And you can see some light pouring in to this dark passageway. And everything in Jaipur is built from this reddish sandstone. Each of the observatories, and we've just flown to Delhi, by the way, which would take us a number of hours by car. And you can see the difference. The Delhi Observatory is surrounded by buildings, also trees. When it was originally built, it was an empty plain. And of course, the buildings make the original use of the observatory more problematic because you can't get readings of objects very low, close to the horizon. And it's smaller in terms of number of instruments, but the instruments themselves are huge. And the color scheme here is a red wash on mortar. And we'll take a little closer look at the Ramyantra, which we didn't look at in Jaipur. It's a cylindrical instrument, measures both altitude and azimuth of celestial bodies. And it's in a pair, like the Jai Prakash. This is the central column, which was used as a sighting guide. Quite impressive, massive. And inside the instrument, the observers were actually able to climb those horizontal walls. There were holes for platform supports and shelves that could be put in between the sectors. So it was possible to get up and take readings from high up as well as down here on the sectored scales. And then to end the tour, we're making a short visit to the Varanasi Observatory on top of the Singh Palace. That's the Ganges River in the background. We're on top of the sundial, looking across to the Digamsa yantra, that cylinder in the background. And here another view of the Samrat yantra, much smaller in scale, of course, than the one in Jaipur or Delhi. And this one is natural sandstone as well, with some lime plaster wash. And lastly, the observatory in Eugen, in its more rural setting there by the river. The Eugen Observatory is actively used. It's a meteorological station, a kind of a museum. The school system uses it to teach kids astronomy. There's a classroom and office building that you see here. As I said, it's not very much a tourist facility because it's not in any of the main tourist centers. So it has a much more private feel to it. And its color scheme is white, whitewash, marble in places. And since it is actively used, there's actually an astronomer on site. And this is a look at the quadrant of the Samrat yantra, where you can clearly see the time markings in hours, half hours, 20-minute sections. And I think this one actually is also right down to 2 minutes in those very fine, tiny markings. And this is the staff, the astronomer on your left, and the staff who were there on the day that I was making these panoramas. So that concludes your virtual tour. And I'll pause the screen sharing here for a moment. And see if at this point there are any questions.
Does the size of the different places, how does that impact, what are the differences in their purposes, if that makes any sense?
Sure. Well, a couple of points here. One is people sometimes ask, why did he build so many? And there were two two aspects of this. One, he was looking for accuracy, and one of the ways to ensure accuracy is to sort of repeat your measurement from a different location. So they were able to correlate or connect the timings and observations they did at different observatories to come to more precise choices. The other is that Jai Singh ruled over a fairly large territory, and one of the ways to kind of establish his authority, but also his beneficence in a way, was to build these observatories so that people in the different regions and territories could have the advantage of being able to have astronomers and do these observations. The one in Delhi was a gift to the Emperor Muhammad Shah. And Varanasi, the family, Jai Singh's family, had many connections there because of people going to school. Varanasi had one of the more important universities or schools at the time. Ujjain is historically a very important religious city, historical, ancient city. So these were kind of prime choices to establish his extensions, if you think of it that way. Why the number of instruments and what's different? Like in Delhi, there are about 5 major instruments. In Jaipur, there are 16 masonry instruments. Many of them do similar things. So in Jaipur, both the Ramyantra and the prakash yantra do both altitude and azimuth positional measurements for sky objects. But they do them differently, and their accuracy is slightly different depending on where the object is. So the Ramyantra is good in the mid-region, 45 degrees or so, but it's not as accurate at the horizon or at the zenith directly overhead. The Prakash, because of its hemispherical shape, is accurate to the same degree no matter where the object is that they're looking at. I'm going to do a screen share here just in preparation. This may take me just a moment. So let's see. You should be able to see a spread from the book, yes. Just, you know, in case there were questions, one of the things I wanted to mention is that the book combines some of the aspects that you find on the website. The website has virtual tours and brief explanations of the instruments and how they work. But in the book, you have a chance to see here sort of more focused and more detailed explanations. This is the Great Sundial, and it shows how the passage of the sun overhead casts a shadow on the quadrant of the dial here. Did not want to bring up a new window. There. So back to your questions.
I'm kind of curious as to how it feels to actually physically be there. You know, the shapes of everything are very different from what you usually experience inside any architecture. And is there any significance to that as far as how the human being would experience the actual being in the actual structures.
Yes, yes. I mean, I think that's a great question. Um, it's one of the things that awed me actually when I first visited the observatories. One, their scale. You are immersed. The buildings um, in Delhi and in Jaipur are so much larger than anything you would associate with astronomy, even being inside a real observatory dome. Um, you're out of doors, but at the same time, you're inside a building. And I'm looking for a couple of images from the book to bring that across. Also, the geometric forms. So one of the things that, dear, Acrobat can be so slow sometimes. Well, let me jump back. So we were here on the virtual tour. I think when you see this presented in this way, the way it is in the book, you get maybe a feeling for this aspect of immersion, of being immersed. You're inside a cylindrical building. You really see only the rest of the world through these small apertures or windows. And so the building itself becomes the place that you're in. I think even though in most of the observatories you walk around, you're in a campus of other buildings, it's a campus unlike any you've ever been in. I think that, again, we'll have a jump here as soon as Acrobat catches up. This is the cover image from the book and the Delhi Observatory. The shapes are just so whimsical in a way, you could say. Many people have said, you know, it's the most amazing 17th century skateboard park because you get that feeling from the ramps and the inclined planes. So there is something wondrous about that. It was purposely scientific, but it comes across, and especially I think in the panoramic interpretations that I've done, they exaggerate the abstractness and curvaceous aspects of the forms. I think that I would have to say that is one of the strong influences.
Barry, I had a couple of questions.
Sure.
So one is that what were the measurements intended for? In other words, that, I mean, I understand the measurement of time, precision with precision, but what about the astronomical observations?
Yeah, good.
Would they have
Good
been used for, right? So that's one question. The second is, can you speak about your own process of making these images?
Yeah. So just briefly, I think it has to be brief. The whole concept of astronomy as we have it in the West is very different from the historical Indian perspective, which is much more tied to the religious systems, belief systems, and in this case, scientifically, astrology, which is really practiced as a science. And the astrologers were quite influential, powerful people, esteemed, had an important role in many important decisions as well as day-to-day decisions in Indian culture. So traditionally or historically, at the invention of the astrolabe, and I'm going to have to be guessing here in the 5th or 6th century AD, the astrolabe had been the instrument that was used. It's an instrument that you look up, position a celestial object, and it has a scale which is tied directly to the place you're observing from, and it allows you to calculate the altitude and azimuth of that celestial object. And because they're generally handheld, even if the larger ones, there are very few larger brass ones, were more accurate. But again, after use of the sighting guides and so forth, the pivots in the instruments lost their accuracy. So Jai Singh wanted to build instruments that would be able to give accurate measurements to the astrologers. And those measurements would be recorded in a table, what we would call an ephemerid. These were the zij that, in fact, that Jai Singh created over a period of years and gave to the emperor as a gift. It was a revision of the astrological tables that had been in use, bringing them up to be much more accurate. I mean, one of the actual prompts for all this was Jai Singh found when he did his initial measurements with smaller instruments that his measurements didn't correspond to what the tables were saying. And he said, this is no good. We can't have confusion. Today's measurements are not what the table says. I'm going to make these instruments basically and figure out what the real data is. So that was his motivation, very much tied into the importance of astrology, and in fact kind of made a connection for him as a leader with the lead astrologers who held tremendous power and sway over the population. So it was also a political move.
Patty, for my second question, actually, Romita Ray had, I think it will, so I can add that to my second question, which is, she said, can you tell us more about your experience of working, collaborating with the local scholars and experts in India in order to understand how these observatories function? How did they contribute to your project?
Great question. And maybe to put it kind of in a chronology, maybe. I first met the Jantar Mantar in 1989. And it wasn't actually something I had planned to photograph, but when I met the observatory, it just was so overwhelmingly beautiful, exotic, that I became interested in it primarily aesthetically as a photographer. And the first photographs, and I'll kind of jump here to the end of the book for a second to illustrate. The first photographs I made, were black and white photographs that kind of capitalized on the form, just the beauty of the form. But I was really intrigued. I have a bit of a science background. I was a physics major for a few years. I've always loved understanding how things work. So I began to just on my own study what I could about the astronomy behind these instruments. And along the way, many years later, a lot of my research, just from web-based research, and also a colleague, Bonnie McDougall, in the architecture department, who's no longer with us, but she and her husband spent many years in India for their PhD research, and as an architectural historian and anthropologist, she knew the sites very well, and we had conversations about them, and she wrote a wonderful article which gave me an insight into some of the political motivations and other aspects of Jai Singh's interests. There's a scholar, contemporary, Anisha Mukherjee, who I have been in touch with, corresponded. She actually wrote the foreword, or not really a foreword, it's an introduction. It's an essay that is at the beginning of the book, which really covers the historical and cultural context. I realized pretty early on in developing the book that to do this service, I needed a real authority. And Anisha Shekhar Mukherjee she's a conservation architect, and she wrote extensively about the Jantar Mantar in New Delhi. So she has an essay at the beginning of the book that covers that background. Some of which, of course, I knew, much of which in detail I did not, so it was informative for me. And lastly, I think the most interesting collaboration, which is going to be awkward for me to illustrate because I'll have to jump, well, maybe not so awkward, bear with me. I began to show the Jantar Mantar panoramas in the planetarium setting, which was just an accident, actually. I had promoted my website to a listserv for planetariums, and somebody wrote back and said, wow, this is really interesting. We're experimenting with bringing new kinds of imagery into the planetarium, not just star shows. And they invited me to show the panoramas at one of the conferences they were holding. And then that led to meeting Mark Subbarao, pictured here, who's part Indian, knew the Jantar Mantars very well. And he's the director of the Space Visualization Lab at the Adler Planetarium in Chicago. So we're here, we were exploring projecting some of the images inside the dome. That's a view you saw on the tour. And that's inside the Adler Planetarium's theater. And the experience of working inside the planetarium was another instance of immersion, being immersed. So bring us back to the book again. So maybe I'll pause here for a moment and just make sure I've answered that question before I go any further. Oh, I didn't really talk about the process. I don't know, Iftikhar, if you meant technical.
So one more, I guess also the local scholars, right? The astronomer you met in the last talk you showed.
Yeah.
Did you have any collaborations with any of those?
Mostly assistants, actually. Although the gentleman, Dr. Sharma, who was the superintendent in Jaipur, was very kind to me on both occasions that I visited, and showed me some of the wooden models that they have in the museum. And also at the time, something to understand, the panoramas that I took were done between 2001 and 2004, just at the beginning of the technology for doing this kind of immersive panoramic photography. And at the time, the sites, while they were popular, the tourist pressure was moderate. So it was still possible to gain access to parts of the observatory that you can no longer go into because of the number of tourists that come there. And he was very kind, actually, to unlock the gates, to let me down into the Jai Prakash, unlock the gates so that I was able to actually climb to the very top of the gnomon and take panoramic photographs from up there. But in terms of knowledge, there wasn't very much exchange or collaboration there with people at the observatory. Well, I take that back. I have to include now my current collaborator in New Delhi, and that's Dr. Rathnasri, Nandivara Rathnasri. She's the director of the planetarium there, the Nehru Planetarium. And she also was incredibly helpful in my visit in 2004. She kind of struggled with the Archaeological Survey, who is kind of the manager of the historical site. And the Archaeological Survey is very conservative and very hard to work with on sort of on a short-term timescale. And to get permissions to go in with a tripod and things like this is complicated. It's a bureaucratic thing. So she was able to run interference because she works on the site so often. She works there with school kids doing measurements. And she's been incredibly helpful. I actually recently had a Zoom conference with her and Mark Subarao coming from the Delhi Planetarium as sort of one of their programs. So yes, the folks on the ground there have certainly helped. But actually a lot of the research was delving into books. There's some real scholars, Sanskrit scholars, mathematical scholars, some who had been at Cornell and are now elsewhere, but that maybe gives a little background. So the other technical aspect of doing all this was taking the panoramic photographs, and that it was done, as I said, in between 2001 and 2004. And of course, the technology has advanced tremendously. At the time, the panoramas are made up of something like 30 individual photographs, and they all had to be stitched together in computer to create what is essentially a sphere, as though you are standing on the inside looking at these little photographs that have all been pasted on the inside of the sphere. And then the software in the computer interprets that and provides the viewer a kind of a window into that sphere that you can move around, and it gives the illusion as though you're standing there. So what I found interesting in all of that, and I'll go here in a moment, is that when you take the spherical panorama, which works beautifully as a kind of a literal virtual tour like the one we did, when you take it and stretch it out so that it's flat and a view like this, which is a panoramic view, but and I would say over here on the left is actually the continuation of what's over here on the right. What's on the top is what would have been over your head, and what's on the bottom, or not quite at the bottom, is what's down below you. So the visual information in the bottom gets stretched. Same in the top, but you can't see the stretch because it's just happening in the sky. But people find these very challenging to understand. They're exotic, beautiful looking, but the idea of the book was to make these panorama renderings full spreads so that you can open the book and look pretty closely at it. And I'll back up here. The book even includes an explanation of how to understand them. So here you see, this is a scene very much the way you would see it if you took a picture with a camera. And here's another scene on the left, kind of just also the way you would see something if you were just looking straight out from your camera. Well, both of those scenes are there inside the bigger panorama. You just have to narrow your vision down and look. But this gives you this whole sense of being able to look at the whole observatory from this place in one glance. And it's the concept of immersion that I incorporated on the book. It became really a major idea of the book. About halfway through the design was when I was actually working in Chicago at the planetarium. And it just hit me, wow, here I am. The book has to somehow do this. So well over half of the book is just photograph after photograph, immersive views, so you can have that sense of looking at leisure. I also want to back up to one thing since I had the book. And that was, we had talked about how the observatories worked at night, because all of our virtual tour is in the daytime. So it was very special. I was not really fortunate to ever be there at night. It's one of the things on my wish list. But this gives you an idea what it would be like at night. You're down inside the bowl instrument, which you saw in the daylight, and you'd be looking up through this sighting guide right here, and the astronomers had some kind of a visual sighting guide that allowed them to translate the line of sight from a celestial object up in the sky through that little pinhole aperture and down onto the scale below. We don't have any existing examples of what those actually looked like. We haven't been able to find them. There was a fire apparently in the museum at some point, and if those objects had been there, they were destroyed. But this is what it was like. This is how it was used.
Sorry, go ahead.
Go ahead, no.
No, there's another question. So I don't want to interrupt you if you're...
No. I was going to end the screen sharing.
Okay. So Romita Ray said, thank you, stunning photographs. The next question is by Mary Woods. She says, dear Barry, congratulations on your stunning work and Yale's publication of your book, which I may remind the audience that the book is available from Yale University Press.
Yes, and also Amazon.com. And I say that only because Yale has had some difficulties with their shopping cart, apparently. Oh, and that's another thing which I completely slipped my mind. You can tell I'm not commercially oriented today, but I have discount flyers, which I will put a link to the flyers in the chat, if that makes sense, when the talk is over. It's a 25% discount if you order from Yale. So that may be something that people are interested in. Amazon is kind of an easy, ubiquitous source. There are independent booksellers as well. Yale provides a list of those. And then if you're at the jantarmantar.org website, the website that I built, you can see an extensive preview of the book. And there is also a shop on the website, but I'm not competing with Yale. I don't actually sell plain copies, but I do sell author-signed copies from my website. So if anybody wants to order one with a little inscription from me, it's basically the price, the retail price of the book, plus a little bit of postage. And also prints of the panoramas are on sale in the shop there too.
Thank you. So the question from Mary is this, two questions actually. Speaking of the Archaeological Survey of India, can you tell us of architectural conservation challenges posed by the sites, any of the sites? The second question, and the question is, what is the condition of the remarkable instruments? It's wonderful that the Eugen Observatory is still working and an educational site. Can you tell us if there is other programming around the other sites in Jaipur, Delhi, and Varanasi.
Sure, yeah. Well, see if I have, remind me if I don't cover all those points. Um, there are conservation efforts both in Delhi and Jaipur. Um, Money is probably the biggest obstacle because these aren't competitive in the way the more ancient sites like the palaces and temples, the Taj Mahal, for example, which are sort of tourist income drives the budgets for these places. Archaeological survey is responsible for an enormous number of heritage sites. The Jaipur Observatory gained recognition as a World Heritage Site, I think, in 2012. And that significantly boosted their leverage, their ability to get funds. And of course, they were always doing more to preserve that site. Its location just outside the Palace Museum in Jaipur gave it much more visibility and also made it more important to keep it in good shape. When I was working there, there were ongoing efforts to repair things and resurface things. But you may have noticed in one of the close-ups of the yantra, loads of graffiti on that yellow wall. That was in 2004. That now is much more clean. I've seen photographs of the Jaipur Observatory, and it is much better looking. But parts of it are closed. You can't get close to the Jai Prakash as you could before. There are other restrictions, mainly because I think of the number of visitors. Of course, that's right down at the moment, but before the pandemic, there were well over 1,000 visitors a day. Delhi has a different situation because in the heart of the city, it's near a very busy transit hub, and it is also just outside the observatory is the site of kind of the popular protests have a protected place where anybody who wants to run a protest kind of can bring it to that place. Public can gather there. So it is also open to the public in a sense, very low admission fee, and it functions as a park. A lot of people take their lunch there. It isn't as well protected. When I was there in both 2001 and 2004, there weren't that many staff who could oversee. Kids could run around, jump on the surfaces, walk in places that wouldn't be good. So there's a conservation problem there in terms of the places not being protected. Anisha and Mukherjee has been very involved in the Delhi conservation. They did add, for example, a kind of a public, a new building that's an interpretation center, which wasn't there when I was there. I think they've added lighting at night, so it's not quite so easy to sneak around. I'm sure there are many things they would like to do. They'd probably like to take the palm trees out because they weren't really original. And I'm sure they'd love to resurface those original surfaces and do new calibrations. But all of that would be a tremendous amount of money. Eugen, as I said, is more protected because it's in use and the local government there takes kind of ownership. In New Delhi, the Park Hotel system, which is a close neighbor of the observatory, has adopted it as a kind of a project where the private sector has some fundraising obligation and contributory obligation to serve the community. Let's see. I think that's all I can say about conservation. But in terms of current use, as I said, Eugen is, well, I'm speaking when I was there 2004. I don't know, but I presume that a lot of their teaching activities would simply be continuing. In Jaipur, the educational programming is primarily through guides, and it has gotten better because I think now the guides have to be approved by the Rajasthan government organization that manages the observatory. But I don't know if outreach activities or like school visits and things like that would be handled in ways other than with the guides who are working for the observatory. In New Delhi, it's very different, and it's definitely an active project of the planetarium there. If you go to the planetarium website, you can join groups that are involved kind of as a hobby, and they meet and do observations from the planetarium. So that's about it. Tell me if I missed part of the question, though.
No, that was good. Any other questions? Thoughts, comments? Well, wonderful. Thank you, Barry, for your...
You're welcome.